So, section 20.2, um, ultra hot interstellar gas. These are clouds that are, much hotter than the 10,000 Kelvin for the neutral hydrogen. Um, the ultra hot clouds are in regions of space where the temperature is millions of Kelvin. We find them because we find regions where the oxygen ion has been the oxygen atom has been ionized as many as 5 times. So 5 electrons stripped off it, which does not happen anywhere in normal, you know, chemistry that we could approximate, you know, millions of Kelvin. And then molecular clouds, these are where the gas is beginning to cool off enough that it's condensing. So we're talking about regions that are in the range of 10 Kelvin. Um, and as those molecular clouds condense, they eventually get enough ions close enough together to start forming a star. So 20 to 30% of the mass of the universe is in molecular clouds, even though they are less than 1% of the space in the galaxy. So then we're going to move on to 20.3 and talk about dust. So, I mean, why do we care about dust? Dust is nothing, right? Dust is the stuff that your mom makes you dust the shelves because it's annoying. Except that in astronomy, dust is extremely important, for several reasons. The dust is what is forming, collecting around interstellar, protostars. And so we look down here at figure 20.11, Horsehead Nebula, which in the visible light range, in the A picture, you see this thing sticking up out of the cloud, and we can't see through it, we can't see into it. We look over in picture B using infrared, and we can see through that into that nebula and see the protostar that is forming right there. As the stars form, when they start fusion, that T-Tauri wind blows the dust out, and then all of a sudden we can see the star. But during the formation times, we can't see it. Dust is important because it blocks our view of things. It does emit in infrared. So light comes up, hits the dust particle, blocks our view over here, but then the dust particle gets warm and emits infrared. So we can see the dust clouds in infrared. The other thing that they do is dust particle, light ray comes in, hits dust particle, and gets scattered into the red. And so stars often look redder than they are if there is a dust cloud between us and the star. So we have to be careful to not accredit that star to be hotter than it actually is. Actually cooler than it actually is. I should wake up and have another cup of coffee. And then interstellar grains. Um, we want to come down to 20.16. And so these tiny particles, um, have a core of various different molecules and then a mantle around the outside of basically ice. Remember, ice is a chemical structure, not necessarily a chemical composition. So you can have water ice and methane ice, and so, but that is the majority of the information that I want you to get out of chapter 20. I do want you to look at the other sections, and then it's time to think about your discussion post.